Today we are starting with the first chapter of class 12th, solid states. Matter has three physical states: solid, liquid and gas. So we are studying solid state. Solids, as we know, are rigid. Why they are rigid? Because they have definite shape and volume. Now, types of solids. Solids are of two types: crystalline solids and amorphous solid. Now, first is crystalline solid. In crystalline solids, the particles are arranged in a definite pattern. While in amorphous solids, particles are arranged irregularly. So we can say that they show short range order, while crystalline solids, they show long range order. Now, what is the meaning of the particles arranged definite pattern they are forming, and particles here are arranging irregularly? They show long range order, and here they are showing a short range order. To understand this, I am taking the arrangement of particles. Like here, these particles are arranging. See, these particles are forming a definite pattern. If a definite pattern is formed by the particles and we keep on going, and this arrangement will keep on going like this only, that means they are following a long range order they will follow, and they are forming a definite pattern. But in amorphous solids, if we see the arrangement of the particles, suppose we have arrangement of particles like this. So like this we have, for example, arrangement of particles. So no definite pattern is formed here. So arrangement is a short range order. The order will be followed only till some part. After that it will become irregular. So these are amorphous solids, and this kind of arrangement if we have in particles, then these solids are called crystalline solids. Next property of crystalline solids is they have sharp melting points. The melting points of crystalline solids are sharp. While amorphous solids, they melt over a range of temperature. Sharp melting points means at one particular temperature only this solid will melt, and no matter how many observations we will take, the melting point of that solid will remain the fixed. Only one melting point is there for a one particular solid under the same conditions. While here, the amorphous solids, they melt over a range of temperature. There is no fixed melting point for amorphous solids. Like plastics are examples of amorphous solids. They have melting point, for example, 100 to 120 range we are giving. So sometimes melting at 100, sometimes melting at 110, sometimes at 115 degrees Celsius like this. So there's a range of melting point here. Third property, crystalline solids, they show anisotropy. While amorphous solids, they show isotropy. Now, what is the meaning of isotropy? Like if we are trying to calculate the value for electrical conductivity or refractive index for a solid in different directions, when we try to calculate these values, the value comes out to be same. That means these are isotropic in nature. While here, anisotropy means the value of these properties in different directions will be different. The reason for this thing is, like I'm taking the arrangement of particles in this solid. For example, NaCl we can take. So Na plus Cl minus, Na plus Cl minus, like this they are arranging. Now in this arrangement, in different directions, the value of these properties, why it is different in crystalline solids. See, in this direction, when we try to calculate these values, see which particles are coming. Now here, if I'm taking this direction, so see which particles are coming in the way. And if we try to take this side, see which particles are there. So in different directions, different kind of particles are coming. That is why the value of these properties is different in different directions. While in amorphous solids, in different directions, approximately the same kind of particles number will remain the same. That is why these values will remain the same in different directions. Now, next example of crystalline solids are ionic solids. Any kind of ionic solid, covalent solid we can take. And here example is plastic and glass, like I told you. Plastic and glass are examples of amorphous solids. One more property here. They show a clean cleavage. And here we have rough cleavage or irregular cleavage we have. What is the meaning of cleavage? If we try to cut a piece of crystalline solid, the two pieces that we'll get, see this cleavage, this is a clean cleavage, we are getting a smooth surface here. But if we try to cut an amorphous solid, then we are not getting the clean surface here. We are getting an irregular surface. This is called that they have irregular cleavage, and these they have a clean cleavage. So these are the differences between crystalline and amorphous solids. And one thing important that we should know about amorphous solids is these are called pseudo solids or supercooled liquids. These are not actual solids, these are false solids, these are pseudo solids or also called supercooled liquids. Now based on this, we have one very important question. Glass of the window panes of some very old buildings are found to be thicker at the bottom. Why the glass of very old building, they are very thick at the bottom and they are thin at the top? The reason is glass is amorphous solid. Or it is a supercooled liquid. It is a liquid, but it is supercooled liquid, so it will freeze and change to solid. But it will show the properties of liquid like fluidity. So particles of glass are moving, but they are moving very slowly and they are collecting up here at the bottom part. That is why the glass here will become thick. This is a reason because glass is actually an amorphous solid. So after knowing crystalline solids and amorphous solids, our next topic is now classification of crystalline solids. Crystalline solids are further divided into 4 types. These types are ionic solids, covalent solids, molecular solids, and metallic solids. This classification is based on the type of particles in these. Like in ionic solids, the constituent particles are ions. Ionic solids are made up of ions, positive and negative ions. While covalent, these solids are made up of atoms. The constituent particles here are atoms. In molecular solids, the particles are molecules, while in metallic solids, these are positive ions, also called kernels, and mobile electrons. So these ions are making these solids. Ionic solids are made up of ions, positive and negative ions. Covalent are made up of atoms, and molecular are made up of molecules. Molecular solids are further of three types: non-polar, polar, and hydrogen bonded. So based on the type of particles, these solids, crystalline solids, are of four types: ionic, covalent, and molecular solids. Now all these we have to study one by one. So first I am taking is ionic solid. In ionic solids, first we are taking their constituent particles. Like already we have done this part. Constituent particles. Then which kind of bonding or attractive forces are there in these solids? Next are the properties of these solids. And last we are taking examples of these solids. So now already we have done the constituent particles in these solids are ions. Example is NaCl. So NaCl has positive ion Na plus and negative ion Cl minus. The forces in ionic solids are very strong forces called electrostatic forces, or also known as Coulombic forces. Properties of ionic solids: they are hard because the bonding is very strong but brittle. Second, they are insulators in solid state, but in molten state or in aqueous form they conduct electricity, but conductors in molten state and in aqueous solutions. Since the bonding is very strong, the melting points are very high. Example: NaCl, MgO, CaF2 are examples of ionic solids. So the constituent particles in these, bonding in these, the properties of ionic solids, and examples of ionic solids. After ionic solids, we are moving on to the second type of solids, which are called covalent solids, or also called network solids. Covalent solids or network solids. The constituent particles here as we have done are atoms. Then which kind of bonding or attractive forces are in covalent solids? Next, properties. And last we have examples of covalent solids. The constituent particles in these are called atoms. Covalent solids have which kind of bonding? Covalent bonding formed by sharing of electrons. They are hard since this bond is also a strong bond, but exception we have is graphite. Then insulators, there are no free electrons or ions in these, so that is why these are insulators, except graphite which has free electrons. Example is carbon as diamond or as graphite, and SiO2. So this is covalent solids. But why these are called network solids? Actually, these are giant molecules. They are very big molecules. Like we know the structure of diamond, one carbon atom links to 4 other carbon atoms, and further they are linking with more carbon atoms, and like this the structure will extend and they form big size molecules. That is why these are known as network solids. The third type of solids are molecular solids. And like we have done before, these actually further are of 3 types. Constituent particles, bonding or attractive forces, then we have properties and examples of these solids. The first category in this is a non-polar molecular solid. In non-polar molecular solid, the constituent particles in all categories are the molecules only. But which kind of forces are here? In non-polar, weakest forces, dispersion, or also called London forces, are there. Forces are very weak, so they are soft, they are insulators and low melting points. Example, noble gases and non-polar molecules like H2, I2, CO2. All these are examples of non-polar molecular solids. After non-polar molecular solids, the second type of molecular solids are polar molecular solids. In polar molecular solids also, constituent particles here are molecules, but since these are polar, so there will be poles, and hence the forces are dipole-dipole interaction, little stronger than the dispersion forces. So these are not very strong, that is why these also are soft. These are also insulators and they also have low melting points. Example is HCl, SO2, the polar molecular solids. The third category is hydrogen bonded. In this category also, the constituent particles are molecules, but now a word bond is here, hydrogen bonded. So little stronger forces are there which are known as bonds, and these bonds are called hydrogen bonds. So hydrogen bonding we have in these solids. Properties, since the bonding is strong here as compared to these forces, so they are hard, but these are also insulators because they have molecules, not ions or free electrons, so they are insulators. But low melting point because bonding is not very strong bonding as compared to the covalent bond or ionic bond. Example is water and ammonia. These are hydrogen bonded molecules, and we have done it in 11th class. Why there's a hydrogen bond? whenever electronegative elements like fluorine, oxygen or nitrogen link with hydrogen atoms, then there is a hydrogen bonding. This is the third type of the solid, crystalline solid. Now, the fourth type of crystalline solid is metallic solids. In metallic solids, the constituent particles then the bonding or attractive forces in them, properties of metallic solids, and examples. So first, like constituent particles, we have done are positive ions, also called kernels, and mobile electrons are there. Bonding is metallic bonding. Now properties are the properties of metals here. They are hard, they are malleable, they show ductility, so they are ductile. Metals are conductors of electricity because there are electrons, and they have high melting points. These are the properties of metallic solids. Examples of metallic solids: metals we will take here, and alloys also we can take. Iron, copper, silver, magnesium, gold, all these are examples of metallic solids.